Hi everyone, welcome. In this video, I'll show you how to do polynomial long division. So you have a polynomial divided by something, and we can set that up as a long division problem, similar to what you learned when you were first learning arithmetic. So here we have our divisor and our polynomials inside, and what we're going to do is look at the first term here and the first term here to decide, okay, x times what would give me x cubed? Well, that would have to be x squared. So we put that x squared right up there, and then we multiply here and here. So we're going to say x squared times x would give me x cubed, and then x squared times 1 would give me x squared. All right. And now, similar to division problems from arithmetic, we're going to subtract. Now, a very handy way to think about this is subtracting is the same as change the signs and add. And thanks to my student Lindsay K for mentioning that phrase, because it's very helpful in this process of polynomial long division. Change the signs and add. Great. So those cancel out, and then this 6x squared and a negative x squared gives us 5x squared. Bring down the next term. Okay, so x times what would give me 5x squared? That would be positive 5x. Multiply 5x times x gives me 5x squared, and then 5x times 1 gives me a positive 5x. Ready to subtract. To subtract, we change the signs and add. These terms cancel out. This negative x and a negative 5x give me negative 6x. Bring down the next term. All right, so here we say again, x times what would give me negative 6x? So that would be negative 6. So negative 6 times x is negative 6x. And then negative 6 times 1 is negative 6. Ready to subtract, we change the signs and add. These terms cancel out, and then the negative 30 and a positive 6 gives us a negative 24. So we can't do any more dividing because x won't go into that. So we can think about that negative 24. Well, that's our remainder, and we put that over our divisor, x plus 1. And I like to write it this way. In some books you might see like minus the 24 over x plus 1, but I like to write it plus that negative 24 over x plus 1. It makes it very clear that that's a negative 24. Let's go over here and talk about what does this process answer for us? Well, one thing is we can determine, is negative 1 a 0 of p of x, of that polynomial? Well, no, it's not, because we got something other than 0 here. If you get a remainder, anything other than 0, that is not a 0. The negative 1 or whatever number you've got there is not a 0. Is x plus 1 a linear factor? Also no. The other thing it tells us is that p of negative 1 equals negative 24. In other words, if you plug negative 1 into this polynomial here in the numerator, you will get the result, negative 24. So in this example, similar to the first problem, we've got a polynomial being divided by something, and so I've set up this problem over here. And again, we're going to go through the same steps. We look at the first term here and the first term here. X times what would give me x to the fourth? That would have to be x cubed. X cubed times x gives me x to the fourth. And x cubed times 2 gives me a positive 2x cubed. Ready to subtract, so I'm going to change the signs and add. So here, these cancel out, and then the 5x cubed and the negative 2x cubed give me 3x cubed. And then I bring down the next term, plus 6x squared. All right, again, I look at the first term here and the first term here, and I think, okay, x times what would give me 3x cubed? That's going to have to be plus 3x squared. So now I multiply this way. 3x squared times x gives me 3x cubed, and 3x squared times 2 gives me plus 6x squared. Ready to subtract. Now I'm going to change the signs and add. Now in this case, both these cancel out. All right, so I bring down the next term. Let's get the right color here. Bring down the next term and the next term after that. All right, x times what would give me negative x? That would be negative 1. So negative 1 times x gives me negative x. Negative 1 times 2 gives me negative 2. Ready to subtract? We change the signs and add, and now both these terms cancel out and we get a remainder of 0. So what this tells us is that negative 2 is a 0 of our p of x. In other words, when we plug negative 2 into this polynomial, the one in the numerator, we would get 0. And so that also tells us that x plus 2 is a linear factor. So here's one more example of polynomial long division. Now, as promised, there will be a separate video about synthetic division, which is a system you can use for the other cases I showed. Now, in this case, notice that the divisor, and the same was true for the first problem, the divisor is to the first degree, x to the first degree. But in this case, the divisor is of a higher degree. So anytime you have x to a higher degree than 1, you're going to use long division. Synthetic division won't work in those cases. All right, so how do we set that up? Well, our startup is pretty much the same. But the other thing I want to show in this example, and this will be true for all these division problems, is when your polynomial here skips some terms, it's helpful to put in 0 placeholders, and you must do that in synthetic division, certainly. So let's say, okay, we've got x to the 5th, and notice there's a no x to the 4th term, but I'm going to put in a 0 placeholder for that, just in case something comes up where I need to deal with an x to the 4th. And we do have an x to the 3rd term, so that's minus 3x to the 3rd. There's no x squared term, so I'll put 0x squared and also 0x to the 1st. So now I'm ready to go through the same process. So we look at the first term here and the first term here. All right, x squared times what would give me x to the 5th? Well, that will be x to the 3rd. So x to the 3rd times x squared gives me x to the 5th, and x cubed times 1 gives me a positive x cubed right there. And again, same as before, we're ready to subtract, so we change the signs and we add. So these cancel out, and here we have a negative 3x cubed and a negative x cubed, so that's going to give me negative 4x cubed. And I really don't have any other terms to bring down at this time, so I'm just going to leave it as it is for the moment. Again, I look here at this first term and at this term here, and I say x squared times what would give me negative 4x cubed? Well, that's going to have to be negative 4x. So negative 4x times x squared is negative 4x cubed, and then negative 4x times 1 is negative 4x. Now, here I am going to bring down this 0x term because this is where this is helpful. I'm ready to subtract, so I'm going to change the signs and add. These cancel out, and then this 0x and a 4x give me a positive 4x. So now keep in mind, this is the remainder. So our final expression is going to be plus 4x over our divisor, x squared plus 1. So this is our final answer up here. And I will place a link for the synthetic division in the description box. Thanks, as always, for watching.